everyone, I am Punyashri AG from 4th year EC and today we will be looking at interpolation. So let's get started. What is interpolation? Interpolation is a type of estimation, a method for constructing or finding out new data points based on the range of discrete set of known data points. So what does it do is we are approximating the value of unknown data points with the knowledge of already pre-existing points. But why would we need this interpolation in image processing? Let us look into a simple example. Consider this 3 into 3 grayscale image given over here, the one in black and white. So before heading towards 2D interpolation, let us take a step back and look into 1D interpolation. Let us say I need to upsample a signal where the signal is given by x of n 1, 2, 3, 4, 5. So let us say I have to sample this frequency with twice the initial sampling frequency. So whenever a signal is upsampled, it just produces an approximation of the sequence that would have been obtained by sampling the signal at some higher rate and generalizing it. Let us say some signal is upsampled by L times. The whole process can be split into two major steps. And what are those? So whenever a signal is upsampled by L times, what do? We first expand the signal. We create a new sequence xl of n comprising the original samples separated by L minus zeros. And the second step is the interpolation. What is that? Whatever the discontinuities we introduced in the previous step where we had zeros, those will be now smoothed out with a low pass filter. So let us have a look into linear interpolation. This over here is the original sequence. Now V of n is the upsampled sequence of x where it is sampled where x is sampled by 3 times, and so we have introduced two zeros in between every consecutive sample. And now these discontinuities, this whole signal is passed into low pass filter and reconstructed back, and that is how we get the smoothened function of the V of n. And the discontinuities are removed over here and we have approximated their values. Now let us look into 2D interpolation. Let us say I need the previous 3 into 3 image to be converted into a 7 into 7 grayscale image. So how would the pixel mapping look like? What would my first step be? Like, to convert a 3 into 3 image into 7 into 7 image, I would introduce two new rows in between every consecutive row and two new columns between every consecutive columns. And how would now pixels be mapped? The simple logic could be to retain the pixel values of the original image. So whatever the original pixel values were there, they will be correspondingly mapped to their position in the new image. And what about the newly introduced pixels? Their intensity value have to be found out, and this is where interpolation comes into picture. So generally in image resizing, image rotation and geometric correction, we use interpolation. So what is resizing image? Resizing image is an image resampling method. Okay, what is meant by resampling method and resampling method, and does image resampling and image resizing mean the same? No, they don't. So image resizing is changing the size of the image without changing the number of pixels in the image. So this is nothing but increasing the dimensions of the pixel, height and width of the pixel. Image resampling is changing the size of the image by changing the number of pixels in the image. So that we did earlier. We changed the 3 into 3 image into 7 into 7. Now let us have a look at few interpolation methods. Nearest neighbor interpolation. This is the simplest interpolation method where we go into every new pixel value, pixel position, and we check its nearest neighbor, and whatever the value of that nearest neighbor is, we allot this new pixel also the same value. So over here in position 1, 2, we go check out its nearest neighbor, which is nothing but the 1 in 1, 1. So its intensity value is 0, so we allot it 0. Then we go to 1, 3, and over there we look at its nearest neighbor, which is at 1, 4, so 255. the same intensity value will be given over to this pixel at 1 3. Similarly, the whole image uh, the whole image is interpolated using nearest neighbor, and you can just check over here how the values are being allotted. So this is how the resized image would look like, original image and the resized image. Nearest neighbor is very fast to compute, very simple to compute, but has major disadvantages like uh, it straight edges will be distorted severely and the image will be pixelated. So you might have observed, like whenever you resize an image, enlarge an image, quite a few things appear pixelated. And why does this happen? Because this is what nearest neighbor is doing. It is just looking at its neighbor and it is just duplicating the neighborhood. And this is why the image gets pixelated, and this is why nearest neighbor is not often in use. Now let us look into another interpolation method, that is bilinear interpolation method. So in this, instead of just looking at its nearest neighbor, we are going to look at its 4 nearest neighbor and estimate the intensity value from the weighted average of the 4 nearest neighbors. So before going into bilinear interpolation, let us have a look at linear interpolation. So over here I have a 1D array where the values are 100, the other two values have to be found out, and the next value is 200. So in linear interpolation, we consider the 2 nearest neighbors rather than the 4 nearest neighbor. So let us say what would the value, let us see what would the value at second position be. It is nothing but 100 into 2 by 3 plus 200 into 1 by 3. The contribution of the pixel depends on the distance. The more closer it is, the more contribution will be more. So over here in second position, 100 is just 1 block away and 200 is 2 blocks away. So whatever the weight they're just the inverse weights. Like 100 is nearer, so it has weightage of 2 by 3, and 200 is far, it has 1 by 3. Now this can be extended to 2D interpolation. So how do we do? Let us say we need the intensity value at position xy, and that intensity value will be given by this simple linear equation. And how do we get the coefficients over here? A00, A10, A01, A11, and these are obtained by solving this linear set of equations. And there are still more complex way of writing the equation, but let us have a look at it logically. So bilinear interpolation is nothing but repeated linear interpolation. What do I mean by repeated linear interpolation? Let us say I need the intensity value at P. So, and Q12, Q22, Q11, Q21 are its 4 nearest neighbor. What do? I move to each horizontal level and approximate a pixel value at the same vertical alignment as that of P. So over here R2 aligns with P. So we approximate the intensity value at R2. Similarly, we move to another horizontal level. We approximate the value at position R1, which is vertically aligning with P. Now we look at it in vertical direction. We approximate the value of P using the pixels R2 and R1. So what do we do in bilinear interpolation? We first interpolate the values horizontally and then we interpolate it vertically. This can also be further simplified. And how is that? Let us say I need the value at position E, and A, B, C, D are as 4 nearest neighbor. And the total horizontal distance between A, B is Tx, and the total vertical distance between B, C is Ty. So how would the intensity value at xy position E be found out? Now let us consider the pixel at position x0, y0, that is A. So A is A distance away and B distance vertically away from E. So what would the weight of A be? It is nothing but Tx minus A into Tx minus Ty minus B. Why? Because we are going to take the complementary distance. And similarly for position x1, y0, the distance is Tx minus A and B. So over here the weight what we are going to take is A and Ty minus B. Similarly, at position x0, y1, the distance is a and ty minus b. So we are going to take the weights as tx minus a and b. And similarly, in position x1, y1, the distance is tx minus a into ty minus b, and that is why we are going to take the complementary distance, which is a into b. And this is how a bilinear interpolation is done. It is just the weighted average of its four nearest neighbor. So this is how the resized image would look like if we use bilinear interpolation. Bilinear interpolation is fast and simple, but it produces severe visual distortion, blurring of edges, and some unnecessary patterns will be introduced in the image. So this was a simple linear interpolation. How about fitting some smooth function instead of some linear function to find out the unknown intensity values? And that is what is done in bicubic interpolation. Instead of considering 4 nearest neighbor, we take out the 16 nearest neighbor and find out the intensity values. And this unknown values are fitted in a bicubic polynomial. But bicubic interpolation is time taking and more complex, but sometimes promises better results than bilinear interpolation. So applying bicubic interpolation, this is the original image and this is how the resized image would look like. So let us once have a look at all three methods. This is for 1D, which can further be extended to 2D too. So in nearest neighbor, what happens? We never introduce some new intensity values. Whatever the intensity values of the existing, what are the existing intensity values, only that will be copy and pasted. In case of linear interpolation, what do? We relate it linearly, and so over here few intensity values are newly introduced, and in bicubic polynomial, whatever these intensity values are, they are further smoothened out and they are being introduced over here. And now let us have a look at another example. So before this, like, what is an ideal interpolation method? That depends on the type of image you have, and that depends on the computational power. So if the image doesn't have many sharp edges or isn't more complex, then nearest neighbor do also will do a good job. But let us say it has more sharp edges, and then bicubic interpolation might be better. And there is no such thing as bicubic always provides a better result than bilinear. It depends on the intensity distribution of the input image. So whichever the best interpolation method depends on the purpose what you need for. So let us have a look at over here. This is the original image where we have interpolated it 3 times. This is using the nearest neighbor, bilinear and bicubic.